Well, good day, everybody. I'm Michael O'Connell. We have the TIBCO Data Science team with us today. We'll be talking to you about AI and data visualization, the combination of those technologies, featuring some of our new Spotfire data science components, along with Spotfire. I wanted to point out to you the Spotfire online user group. If you go to that URL there, meetup.com, you can join this group and you'll get notifications then of events. We have this online meetup every few months, and there's other information that comes out on our community site around the meetup group. So, for example, there'll be links and so on to today's presentation, along with demonstrations and so on, if you're a part of the registration group or part of the online user group. So today, I'm going to give a brief update on our visual analytics and data science capabilities. Then we'll have two wonderful demos, one on big data parking citations by DJ and one on flight delays by Chai. And then Helene will give a community update at the end with live Q&A. So as the introduction to this, I wanted to talk a little bit about the TIBCO Connected Intelligence portfolio. And this includes our interconnect products, interconnecting data, systems, APIs, people, and processes, along with our analytics portfolio of products for visual and embedded analytics, streaming and predictive analytics, and data intelligence. So let me step through a couple of these before we jump into the demos. These products can be combined into what we call a system of insight, providing insights, identification, and then taking those through to action. And the demonstrations today combine some of those products on the data science and visual analytics side as part of this bringing together AI with visual analytics. The data intelligence part of the portfolio includes our master data management products, our data virtualization product, along with inside of Spotfire, our semantic data catalog, semantic search and data catalog, along with our data wrangling capabilities inside of Spotfire. The items in blue below more of the interconnect side, and the items in orange are the inside of Spotfire components. So briefly, the data virtualization, which is a fairly new component in our stack, provides a logical access layer to a variety of back-end data stores, whether it's a data warehouse or a relational store or a big data store. All of those can be virtualized into a view that allows you to bust across silos, get 360-degree views, and provide that conveniently to your analytics layer, whether that's for BI or visual analytics, reporting, data science, streaming. It's one logical place to go for a system-wide view or a company-wide view of data sources. We've been OEMing this product for many years inside of Spotfire, and we liked it so much. Last year, we bought the company, and we've provided this as a general service to our analytics customers. Once you get your data inside Spotfire, there's a number of tools for wrangling that data, expressions, point and click suggestions around how to join data, how to clean it up, how to engineer some features that you might need in your analysis. While you're doing that point and click, that data lineage that's shown on the page is automatically created for you. You don't have to create that yourself. It organizes all of the work you're doing in preparing the data for your visual analysis and keeps track of it. You can edit it. You can see the details below it. So that point and click combined with the automatic generation of the data lineage is pretty powerful. Now, once you've got the data in that shape, you can very quickly then, through our recommendations, suggestion system, construct dashboards like the ones here, combining brush-linked graphs from the different data sources to tell that story across the data with Spotfire Visual Analytics. The geo capabilities inside of Spotfire are very strong. Bottom right is a contour analysis of weather data. Bottom left is using that same geo analytics, but this time on a shopping mall. So whether you have geography data or other spatial data, you can use our geoanalytic capabilities for analyzing that and combining that into your dashboard. We've made a number of investments recently on the data science and predictive analytics side of the portfolio. So Spotfire, we have spent the last many years creating our own proprietary runtime for the R language. So you can run your R code directly inside of Spotfire. And we've exposed some of that in the menu system for doing things like regression, classification, clustering, and so on. So there's some point and click in Spotfire. There's scripting as well. We've added to those investments firstly with Statistica, which is a data science workbench. You can point and click rather than writing R code, point and click to a variety of machine learning models, and you can save and manage the code that you generate, or the workspaces that you generate from the point and click operation for reuse. And then we also added a new product, TIBCO Spotfire Data Science, based on the Alpine data product that we acquired in 2017. This provides a true data science platform for in-lake or in-DB analytics across big data. We actually inject SQL and Java components into the Datastore that runs the analysis at scale, billions of rows. And in addition to the visual composition interface, we also have interfaces with a Python notebook and other components that allow scripting with Python down into the Spark layer or into the database. There's also a Slack or Facebook-style collaboration interface for managing projects. We'll be showing you today combinations of these products. DJ's demo on parking citations will use the new Spotfire Data Science product. Chai's demonstration on airline delays will use the Statistica product, both combined with Spotfire. Finally, once you've created some insights, either with visual analysis or data science tooling, we provide a number of tools and mechanisms for you to inject those analytics into production operations to impact real-time decision-making, visualizing results, for example, or pushing real-time engines to run in a cloud environment or in an event processing environment like TIBCO Streambase. Or you can schedule batch runs of Spotfire analyses or data science workflows in your operational systems. And Chai will allude to that in her demonstration. So this allows you to combine visual analytics with data science and apply that to the event stream. If you identify some anomalies, we can push that into our case management database for resolution. And we have a number of accelerators for different industry challenges that you can download and use combining the TIBCO products. Okay, so to kick this off, the idea of today's focus of the webinar is to look at visual analytics combined with AI and machine learning and the combinations of the products, Spotfire Data Science with Spotfire, for example. We'll take you through some demonstrations of how these products are used together. Now, we've just kicked off the new season of Sadie F1, and this is a great example of combining data science with visual analytics and streaming. And I encourage you to keep a handle on the race series this year. It's just starting up next week. And there's if you want to read about it, there's an article in Computer Weekly, and there's been a number of other combinations of data science and visual analytics that have been in the news. So with that, I'm going to hand off to Chai to go through the demonstration around predicting flight delays. Chai, can you take it from here?
Yeah, sure. Thank you, Michael. Okay, so good morning, everybody. My name is Chai Lee, data scientist in TIBCO. And in today's demo, we are going to look at this analysis that predicts airline delays. And we are going to analyze historical flight delays as a data scientist. And we'll look at how a data scientist will use TIBCO Statistica to do the modeling and also use visual analytics in Spotfire to analyze the results of the models. Now, the data set that we're using in this demo is a public one, but we can imagine that airlines and airports can use similar data sets to predict flight delays and take measures to improve their operations and also travelers' experience. So first, we are going to take a look at the data in Spotfire. We have here the data displayed in a dashboard, and on the left-hand side here, we have the origin airports, and on the right, we have the destination airports. And on the bottom left, these are breakdowns of delays experienced by various carriers, whether or not there are delays in flights and the percentage of delays. And in the middle here, we have a plot that shows the month of the year, and the days of the month, and it shows the amount of delays experienced by the flights. The darker the color, the longer the delays experienced by the flights. And on the bottom right here, we have merged data with on flight delay with weather data, so that we can investigate the trends of flight delay with weather. So here we are not simply just doing a univariate comparison. And now, with this plot, we can actually narrow down the locations, the airports, by selecting the ones that we are interested in, and the plots below will update themselves. And this gives us the opportunity to look at the trends of flight delays with the weather data by locations of the airports. So now, having taken a look at this data, we are ready to do some modeling on the data to predict flight delays. I'll move on to the statistical workspace. And what we're looking at here is a workspace in Statistica. So the data set that we're looking at here is relatively small, with just about 200,000 rows. And it is hence manageable for us to bring this into memory and into Statistica to build the model. So Statistica is a data science platform, as Michael mentioned, with a wealth of options and modeling techniques that we can use around machine learning. And this view that we see here is actually a flow where we construct a model, train the model, and then apply the predictions of the models onto a set of unseen data. So what we have here is that we bring the data set into Statistica, and then we perform a few operations on the data, subsetting, deriving variables, and we split the data into a training set and a testing set. So the training set is used to train the data. The testing set is something that is held aside, that is not used for training, but will later on run the models that are trained against this testing data to find out the quality of the models. And each operation that we have in Statistica is denoted by a node. These are called nodes, and all these are constructed in a point-and-click manner. So we have here in Statistica a very rich set of algorithms to work with, and we can see some of these in this menu here. In this problem, what we are trying to predict is flight delays, whether or not a flight has been delayed by at least 50 minutes. And we are predicting a true-false value, which means that we are going to use classification algorithms to do this. And Statistica makes it very easy for us to choose the best algorithm. So we mentioned that there are already many options available in Statistica for algorithms. And we can choose them and run them against the training data to train the model. And after that, Statistica can automatically select the best ones based on some evaluation criteria that we select. So here, for classification, we are using 3 different models. We are going to evaluate 3 different models that are going to be trained against the data. Boosted classification trees, card model, and the random forest model. And we can even compare these models within Statistica with those models that are built using R scripts or even Python scripts. So within Statistica, in each modeling node, there is an extensive number of options that we can choose from. This is where we select the target variable, which is the variable that we want to predict whether or not a flight has been delayed by at least 15 minutes. We select as well over here the predictors that we are going to use, categorical ones as well as continuous ones. So this is the environment where data scientists will work extensively in. So once these models are trained against the training data set, we have the models represented here. They are then run against the testing data set against these three models, and then Statistica will find the best model for us. And for a data scientist, apart from training the model and coming up with the model, you're also interested to know what the model predicts, how the model predicts, and how they perform. So we can actually bring the results of these predictions on the test set out into Spotfire. So this node here creates a Spotfire file, an SPDF file, and we can bring that into Spotfire to do an analysis. So let us move on to that, to analyze the prediction results on the testing set in Spotfire. So there are three models that we train in Statistica: the CART model, the random forest model, and the boosted tree model. And we see the results of these three models against the testing set here in Spotfire. So on the top plot, we are plotting on the horizontal axis the predicted probability of the model of whether flights have been delayed for at least 15 minutes. And the vertical axis shows the actual delay, whether or not there is a delay, 1 for yes and 0 for no. And then in the middle plot, we have a different view of this. So instead of having individual data points that are plotted on the top plot, the middle plot aggregates the data points into circles that we see here. Each circle is an aggregation of a data point, a set of data points. So the one that I'm pointing here now is an aggregation of those data points that have a predicted probability. If you look at the tooltip here, the second line, predicted probability of between 0.67 and 0.93. And it shows us that for this group of data points, the observed probability or the observed proportion of actual delays that actually happen is 0.72. So you can imagine that this point is in fact a collection of those points that are darkened out up here. So they are all aggregated into one single point here. So we also have a line that runs straight through the y equals x line that shows us what would happen, the position of the points had the observed probability been exactly the same as a predicted probability. And this gives us an indication of how close the model is in predicting the values. The closer the points, the circles are to this line, the closer the predictions are to the observed proportion. I also like to point out that of the three models here, we can see in the middle plots that the random forest model and the boosted tree models that we train tend to predict high probability of delay of at least 15 minutes relative to the observed probability. We can also see that in the third row of plots here that shows us the correct and incorrect predictions made by each model for those delays that were actually observed and those cases where there were no delays. We see that both random forests and boosted trees, they have a good ability to predict delays correctly. So here with one, these indicate the actual delays that have happened, and the model is able to correctly predict these with a high proportion of correctness. And at the same time, we also see that these two models also tend to have a higher rate of incorrect predictions for cases where there are no delays. So in fact, this has been deliberately set in the settings for the model because we actually applied a weighting to penalize incorrect predictions of delays. In other words, we give a higher weightage of penalty for not being able to predict delays correctly, and this is because we want to maximize customer satisfaction, and the loss of customer satisfaction when delays are not correctly predicted is more costly than not being able to predict delays. So, having known this, we can come back to Statistica to see where this is being set. In the modeling node, we have this misclassification cost here, and this weighting is set in this panel. So now, once the data scientist is happy with the model can now be deployed. And this is also set in Statistica, and we can see here that we are able to deploy models as PMML models, as Java code, and models can also be deployed in a workspace in Statistica itself and run on the Statistica server, and they can be version controlled and shared collaboratively with teams within Statistica. So, having had the model deployed, now airlines and airports can then use that deployed model to predict future delays in flights, and they can use the results to take preemptive actions to prevent inconvenience to passengers. So those predictions can then be displayed in a form that is suitable for users' consumption, for example, in a Spotfire dashboard. And here we have a very simple dashboard showing those predictions. It shows the flight delay predicted for different airports. Over here, the percentage of flight delays for the airports. And also at the bottom here, we see the percentage of flights delayed predicted by the day of the month. So I've come to the end of this demo. And to recap, what we have seen here is that we've seen the data scientists build models to predict airline delays in Statistica. And the data scientist uses visual analytics to analyze the results of the models. And then the chosen model is deployed and the results are displayed and consumed in a tool such as Spotfire. And this can be used by airlines or airports in decision support and allows them to take preemptive actions in case of flight delays. So let us move on now to the next demo, where I'll pass it on to DJ to present the parking citations demo.
Thanks, Chai. So until now, what we saw was data that was smaller, kind of well-behaved, where we were able to glean all of those insights very nicely within the given tools. What happens if your data is massive? So we're talking about millions of rows, several features, not all of them make sense, where you need to craft intelligible features out of the data that you're given. So the next demo talks about the use case where we have big data doing data prep and analytics at scale, then doing a visualization of the reduced data set and creating an interface for business users to see the insights, but also develop a collaboration between the data science teams and the business users. Talking about the project, this comes within the realm of using technology for good. We partnered with a nonprofit, Tipping Point, to look at citations data and evaluate the impact or the burden of those citations on different groups within the data provided. So we looked at it by car and we came across some very startling discoveries that I'll share with you in just a minute. So talking about the tools first, we have Spotfire Data Science. You can see I'm inside the workspace now. So this is what the look and feel of the workspace is, you can see it's very interactive. A lot of different team members can add their comments, add links to the file, and you can sort of trace almost a Slack-like interface for tracing file changes. And if I go to the work files itself, for any of these files, there's a list of activities that tells you what has happened, what are the changes, what are the kind of commits. So you can think of it very coarsely as almost code documentation and change list and commit list. From here, I can click on any one of the files and it's going to open that for me. So let's go in and look at the workflow. This is the workflow that we use for analysis. As you can see, it's a very nice UI-based tool. I can select operators from any of these categories, or I could go in and type something to look for the operators that I want. So XVDF or regression. And once I get that, it's just about dragging and dropping it and configuring it. So the data that we had available was several different tables. We had citations with zip code, we had business locations, location of parking spots, center lines and road information. And as you can imagine, that not only did we have to analyze these individually, but we also had to create a master list of what it looked like together and query all the different pieces together. So I have here several aggregations. Then after we're doing the aggregations, we're joining by it so that we're not creating duplicate rows. And then we're doing correlation analysis, we're doing regression analysis to see how the different variables basically relate with each other. I want to show you unpivot because this is my absolute favorite. When you exceed a certain data volumes, the moment you go above a few thousand rows, if you try to do full joins or if you try to do unpivot in most tools, that would cause it to break. But over here, we're doing in-database analytics of big data. So you can have your data sources to be Spark, Hadoop, any kind of big data source. And then you're doing in-database all of this. So to configure it, and all of that complexity is abstracted away from the user. So when you're working, you're not really thinking about the Spark job syntax that you have to run or the command syntax that you have to run. You're only thinking about the action that you have to take. So it's very easy, just select the columns and specify how you want it to be saved. You can give your output directory. This output directory is also going to be within your big data source so that you can now transfer it from one operator to the other operator. And you don't have to always rerun things from the source. You can just step run the next one. So a lot of these amazing built-in functionalities and optimizations have let us accurately and appropriately create summaries and stats and relations between the different tables that we have. So from here, now that we've looked at this entire pipeline of data join, cleaning, and aggregations, we're actually going to look at the result of it. Let's go in and see actual dashboard. And again, I accessed it from here. So if I just go in and do the Spotfire dashboard, it will open up. But it takes a little bit of time to load up because it's close to 3.9 million citations. And we have data about 1.3 million cars. So this data comes from the city of San Francisco for the year 2012 to 2017. As you saw, we queried with a number of other open data sources that were available. So for example, we took San Francisco government provided center lines. We took SF rent data and minimum wage change history data. So from there, for those of you who are not familiar with San Francisco, let's first just look at what the neighborhood looks like. So here, I've colored it by affordability, and this is still California affordability. So even the most affordable in San Francisco is probably not that affordable. So we start with the white regions. These have low density. There's a lot of parks in this region, sort of the adjacent South San Francisco region. And then we move up in color to the more expensive ones. And once you reach the downtown and the beach areas, the nice views around the Twin Peaks and all of that, it starts to get more expensive. So on top of this, I can actually show you the road. And once we overlay it with the road, you can see that the expensive areas follow the major roadways. So for example, this entire area is expensive. You've got a major roadway here. You've got a major freeway running in this direction. And this is the popular downtown street, but also a lot of internal BART and public transportation runs across these. So these tend to be a little bit more expensive. So our initial estimate was that in these downtown areas, we would have higher ticket amounts, higher number of tickets. Now that we know the geography a little bit, we overlaid it with the ticket data that we had. So now you're looking at the citations view. Every single point is an individual parking citation that has been given out. So it's colored by the amount. So you can see a lot of the citations fall within the 200 to 400 category, but you also have some really crazy expensive citations that go above 1,400, above 1,000, and so on. Now, you can see that this data is very dense. What I mean by that is that two different parking spots are two different points on this map. If I select only the lower end citations, so the $200 to $399, we can see that all of my data filtered by that, and we can see that zoning and location related citations are the most expensive in terms of average amount, followed by street cleaning, followed by plate and registration. And a lot of this density is around the areas that you would expect. A surprising thing that we saw was that a lot of the even expensive number of citations that were given out, they were given out to regular cars like Toyotas, Hondas, Ford. Even if I go to the slightly higher end of citations and select that, you can still see that the economy cars show up as being the highest citations within that category. This could happen simply because we have that many Toyotas and Hondas on the street, or maybe something more is going on. So we decided to look at it by car. On the left, we have the distribution of cars by age, and then we color-coded it to signify categories. The cars that are 10 years or younger, they're called new cars, and cars that are 20 years or older, they're called old cars, and then you've got the other categories. You can see that the patterns for tickets for all the cars are pretty similar. So for example, everybody tends to get more tickets on the weekend, everybody tends to get the most tickets during lunchtime when they're probably, parking in a location they're not supposed to grab a quick lunch or something. Then we start to look at the proportion. So if you look at the total number of cars, about 6.3 are old cars percent, and 60% are new cars. When you look at the number of citations given out, that is pretty much the same proportion. But once we start to look at the amount, so for example, if I show you the amount of citation by type of car, it's close to 7% for old cars, and it reduces to 59% for new cars. And then if you look at the amount that is due, so payments that are totally or partially unpaid, you suddenly see it jump to a 12.2%. And for old cars, that's almost twice their original population in the data. So this was very alarming for us because that means that the burden of the parking citation is heavier for people with old cars. This is significant because there is high negative correlation assumed between income and age of car. So if you're very well-to-do, you're probably not going to be driving a car that's more than 20 years old, with the exception of vintage cars that we filtered out when we were looking at plate numbers and so on. Next thing that we do is actually look at what is causing these numbers to rise. So we look at citations by violation. And within that, you can see that over here, every row is a violation type, and every column represents the car that is affected by that and the amount that's paying for it. So the white block mean all cars, the blue ones are new cars, and the orange ones are old cars. So if you look at average tickets for meter permit-related violations, you can see that for all cars, it's $81. The new cars, it's $81. But for old cars, it jumps to $89. This keeps happening across every category, you know, average overall ticket amount. Average ticket for plates and registration is the worst, where you've got the entire population pays $110 on average. The new cars pay $105 on average, and the old cars pay $136 on average. So there's about 29.52% increase. Now, we calculated the living wage per hour in San Francisco over 2012 to 2017. And we actually saw how much of these amounts translate, how do they translate into minimum wage or the cost of living in San Francisco. So again, we start with the percent cars. You have 6.3% old cars and 60% new cars. If you look at percent number of citations, the percent citations that exceed 1 week of minimum wage pay, 7.9%, 8% of that go to old cars. And the number reduces for new cars from 60% to 54%. Similarly, if I look at citations that exceed 2 weeks of minimum wage pay, it's 8.6% for old cars. And the moment we look at how many citations are outstanding that exceed 2 weeks minimum wage pay, you see that 15% of all old cars are under that category. What this means is people are simply unable to pay the citations that are being charged. Not only the citations, but they're being charged late fees on top of it. A lot of these are citations that you can show a proof of correction and then go back and dispute your original citation. But if you're working 2 jobs, if you're working 3 jobs, you're not going to have 2 days of your schedule to go and do that. This brings us to call of action. So the Tipping Point team, along with the TIBCO tech team at the time, the Alpine data team, wrote to the San Francisco Office of Financial Justice, and we showed them the data, and we showed them with examples what exactly was happening. So if I take the most common ticket that was given out, which is for street cleaning, it has a dollar amount of $68 initially. After 45 days, you have a $30 penalty. After 90 days, we have a $90 penalty. Total amount due at the end of 90 days is $188, which makes its interest rate per month effectively is 58.82%. Compare that to real estate. First of all, there's a grace period allowed to property owners, taxpayers, if they default in making the payments of 69 days, after which they have an interest rate of 10% per annum, which gives an effective rate of 0.83%. So the same city in two different scenarios has two different rates of penalty, and that's really impacting some of the population. So the good thing is that we've seen some movement from the FFMTA, and they're starting to bring in reforms starting March 1. At this point, I will hand over to Helene to show you around the TIBCO community and where you can read more about all of these demos.
Great, thank you, DJ. So yes, I'm going to, there were great demos, by the way, both Chai and DJ. I'd like to provide an update, as we always do in the TIBCO Analytics Meetup, on what's available for you on the TIBCO community. We've got thousands of people actively contributing to the TIBCO community. You all, your peers, and a lot of TIBCO experts. And we can't repeat enough how useful it is, and like to help you sort of point out how to navigate the community and how to contribute to the community as well. So the main sections of the TIBCO community are answers, wiki, exchange, and ideas. And I always start this section by just reminding you of what those sections do for you. So the answer section is where you can ask questions and get answers. So everyone can help answering those questions. They're definitely checked by the TIBCO experts and contributed to if they also actually inspire us to create new articles on the TIBCO community. If we get a lot of questions about a similar topic, we make sure that we enhance the information, or we add some information to the existing wiki articles. Which brings me to the next sections, which is the wiki, and that's where we collect a lot of information on all different kinds of topics. So it can be industry specific or capability specific. So there's a lot of information there, and I'll share a number of examples with you. And the exchange is where we upload templates and accelerators, basically quick starting points for you to help you with your analyses, and I'll show some examples as well. And the ideas portal is where you can vote on existing ideas or suggest new ideas for any of our software products. So, and actually the link to the site is very easy. It's community.tibco.com. And all the trials are available from the community as well. So let's look at this from the site itself. So we had some questions. Actually, is there a sandbox available? I just wanted to point you out to all the trial options that are available. So our most recently acquired products may not have the trial option here yet, but just use the chat in our on our websites, or put a question in the community, and we'll come back to you showing you how you can trial the latest products as well. We'd be very happy to support trials, because it's the best way to find out how useful the products are for the things that you're trying to solve. So I think many of you have worked or used the community by accessing the wiki for Spotfire. So I've shown different ways in the past on how to access the Spotfire wiki. This is one way to do it. What we've done is we've organized all the content from the community by the core capabilities for Spotfire, the more advanced capabilities for Spotfire, and then also industry solutions. And as you browse through this information, you'll find links to all of the other data science products as well. What we've done more recently, or in the last few months, is created this Customer Success Center as well. So if I click on this, what you'll see, it's a little bit more manageable content. It gets updated very frequently, and it shows you the latest of information that's available to you, with some current content and links to information that may be useful for you. What we've also done, which you might find useful to bookmark or share with your with your colleagues is create this essential Spotfire Analytics resources page. So we have a few different ways, and I guess you just need to choose which one you prefer best to navigate all the different resources available. But this explains what I just did, the different sections of the community, and gives you a lot of links to useful information. What's important to see here is that we have the Dr. Spotfire office hours. So this is a session that DJ and others in our team run. It's a live webinar where you can bring in the questions that you have on your actual data and get answers in real time. We actually use all the questions that are being asked on the community to create the agenda for these sessions as well. So it's very much in line with what's currently sort of being asked in the community. We often, if you post a question on the community, we also ask you to contribute or to join our Dr. Spotfire session so that we can answer that question in a little bit more detail. The other link that you'll find on here is for this meetup that we're in now. So I just wanted to make sure that you can always, actually we'll share this link in the meetup itself as well. But all of the videos and all of the related files or links to these meetups are posted on this TIBCO Analytics Meetup community page. So the links to the demos and any further information can be found here. So if you want to look back at some of the videos, you can find those, and we're actually posting them in YouTube as well, and the links will be on this page. So for the previous sessions, for example, you see all the demos listed here, and you can watch them over and over again. So the other thing that I wanted to say is that the demos that you've seen today are part of an initiative and a theme that we've created this year, which we refer to as the beauty and the brains. And we've actually done a lot of live meetups as well. So if you would type up beauty and brain in the community or on Google, you will get referred to this page on the community as well. And actually search works really well, whether you do it from the community or from Google. So if you search for a certain topic and you add TIBCO or Spotfire or TIBCO Community, you usually the relevant page is one of the top hits if you get past the ads. So the Beauty and the Brains it's a webinar. It's this meeting. It's a series of meetups that we've just finished in the US, and we're now planning them for Latin America and Europe in the upcoming months. I'll add the exact dates shortly, but I know there's one in London on May 10th. And that will be an opportunity to meet with our team and with Michael Connell and look at these demos in a lot more detail and meet with other Spotfire and data science enthusiasts as well. So we invite you to those sessions, and you can also find more details in the videos of these demos on this page if you're interested to learn more. The other thing I wanted to show is that we actually, the Spotfire version 7.12 is just out. So if you type in what's new in Spotfire, you will get to the page that has the latest information on the latest version of Spotfire and also all the previous ones. So again, it has a section with links to all the different updates that we've released lately. So depending on the version that you're on, you just click on it and you get brought to the part of the page that has all the information. And this is all updated by our product management team with all the details and the features that are on there. And all these new releases are also in response to what you submit in the ideas section. Obviously, not every idea gets included in a new product, but if you have submitted an idea in the ideas portal and one of those features is included in a new release, you'll get an email update as well to confirm that it's included. Or if you have a great suggestion, but we need some more info, then by submitting it in the ideas portal, you also have an opportunity to contribute and maybe have a conversation with one of our product management team members or engineers to clarify and contribute to that idea so that we fully understand the requirements. So the other thing I wanted to show you is the Exchange. So the Exchange is where you can actually download specific items that will help you get started with certain types of analysis in analytics. So using Spotfire or using a combination of our products in the analytics portfolios we just showed you, and we're constantly updating those. So it's worthwhile sort of keeping an eye on these. We communicate about these also through the Spotfire newsletter and through social media. But there are templates, there are accelerators, just helpful starting points to use machine learning with Spotfire and our data science tools. Some exciting templates, such as the network chart templates for Spotfire. So rather than building this on your own, you can download it and put in your own data and start using it. And we really look forward to getting your feedback. We typically demonstrate some of these templates in this TIBCO Analytics Meetup as well. So if you see one here that you really like and you'd like a bit more detail, then let us know and we'll include it in the next meetup as well. We also have these accelerators that combine all our products, including our streaming analytics products, that really get you to those connected intelligence analytic applications. The other thing I wanted to point out, which is actually the last one, is that we did a really nice analysis for the Gartner conference. So I think I should be able to find it. Yes. So DJ actually put this analysis up here. She worked on this with help of a few colleagues, but created a really nice demo on the data that was made available for a bake-off of the Gartner events that have just completed actually in London this week. So it is an example of, it is actually an analysis to look at the effects of the use of subscription drugs and overdoses issues that are happening. What you can see is how Spotfire is being used to analyze that with exploratory analysis, descriptive and prescriptive analysis. Great use of geoanalytics as well. Some videos here on the site as well as on YouTube for you to see. So what we're really trying to do with the community is share the use cases and the examples of Spotfire so that you get inspired, you can learn some things, you can ask questions, you can also show it to your colleagues to see sort of the art and show the art of the possible of the different analytics tools. So let me get back to the slides. What I wanted to also do is make sure that everyone is aware that we're going to have our big TIBCO Now event in September this year. So we'll start sort of reminding you so you can put this in your agenda. This year the theme is Innovation at the Edge. So we're very excited about this, and we'll have many of you and customers on the stage presenting the value that they create with the full TIBCO portfolio of products. And this is just a reminder to put it in your agenda. So that brings us to the final slide and the Q&A. And I think while I was speaking, DJ has looked at the questions and is going to moderate a little bit for us to see who can answer the questions. And feel free to add them to the Q&A or chat box while we're talking as well.
Thanks, Elaine. That was a great summary. The first question that we have is around how do the different tools, Statistica and Spotfire DS, communicate with Spotfire? That's for Chai.
Right. Okay. In the demo for Statistica, what we did is actually that in Statistica, we exported a data set that is generated with the predictions on a test set as a Spotfire as PDF file, and we import that in Spotfire to visualize it. So the other direction works as well in that we can export an SPDF file from Spotfire and import that file to analyze in Statistica. So the primary communication between Statistica and Spotfire and also Spotfire Data Science is through the exchange of SPDF files. What this allows us to do is to leverage Spotfire's powerful data engine to visualize the intermediate results of the modeling. So for instance, you may have done something to prepare the data in Statistica, and then you do the predictions on the testing set. So after important intermediate steps, you can visualize the data by doing an export of the SPDF files in Spotfire.
Great, thanks. The second one that we have is around the same lines, that Spotfire has its own data science and modeling functions. So when would you use a tool like Statistica?
All right. So yes, that's right. Spotfire has its own modeling functions, and as a reminder, those functions are the menu functions for classification, regression, and a number of others. There are also teradata functions that you can write yourself in R and run in the TIBCO R engine, TER, within Spotfire. So that is suited for users who are exploring data science with the point and click menus in Spotfire, or teams that are already using R and has a strong practice in R and are able to develop R scripts for the teradata functions. So Statistica, on the other hand, is a data science platform with a very rich set of algorithms, and that is dedicated to data scientists, teams of data scientists, and it provides better productivity for data scientists with the tools available, like what I showed just now in the demo, for models to be compared against each other, and for Statistica to select the best model for the data scientists. It also provides capabilities around model management and governance of models, and not to mention deployment. We saw just now that the models can be deployed as workspaces in Statistica, can be deployed as PMML, can be deployed as code. So there are these many options available within Statistica to manage the entire life cycle of models from the creation to the deployment. So if you have a team of data scientists, that's a tool for you to consider, and especially if you are interested in an environment that is point and click, which doesn't require you to code to build out the entire model management framework yourself. So Statistica would be a good tool.
Thank you. The last question that we have is around what all data sources can we use in TIBCO Spotfire? Can we use SAP as a backend? So you can have a number of data sources that we have connectors built out for that ship with the product. You don't have to pay anything extra. I've given you a list of those just in the chat. I sent you data access documentation for Spotfire. If a connector that you want or a custom source is not on there, you can always leverage IronCiting or TIBCO Enterprise Runtime for R to connect to those sources. A lot of times you can even use the generic JDBC, ODBC connections to data sources. So those are all the questions. Thank you for joining us on TIBCO Analytics Meetup this time. If you have any more questions, please tweet at us or post them on the community page for the meetup.